Hello everyone, on this video I'm going to talk about the example of the 7.7 okay in the textbook. Okay, and I found some people will have some issues for this example. Okay, let's look at the problem. The problem is not difficult. It said there's a member AC here, and there's a support C, and also the other member for the support is AB. Okay, AB also for support of the AC. He said we have a vertical force 3 kilonewton here push down. He said determine the distance x and let's make the normal stress of AB section and the normal stress at the C section is the same. Okay, and give you the cross-section area of the AB section and the support C. One is 400 millimeter square, the other is 650 millimeter square. Okay. For this problem, first of all, you need to draw the free body diagram of the AC. And then use the rigid body equilibrium, and then use this criteria: the average tensile stress in the rod AB, and the normal stress at a smooth support C is equal. Okay, to solve the problem, to determine the x. Okay, but some people, some students will have the issue is, yeah, I know we have to do the rigid body equilibrium on AC section, but I don't really know the direction of the force AB and force C. I don't know the direction of force AB and force C. Under this condition, could I really can solve the problem? Okay, because the picture here, he is the right force direction. This here is the right force direction. Okay, the FAB is pointing up, FC is also pointing up, but what if initially I assume the wrong direction? Could I still get the correct answer? The answer is yes. Even if initially you assume the wrong direction, you still can get the right answer. Okay, let me show you what really happened. Okay, so let's start with it. Okay, so let's switch. Okay, we have to do the free body diagram of the member AC. Okay, AC. Okay, let me point out this is A, this is C. Okay, so the problem here, I address this again. What if I don't know the direction of force AB and force C? Okay, could I still get the right answer? My answer is yes. Okay, let me show you. Okay, I should say wrong initial assumption. Wrong initial assumption. Okay, so I don't know the direction of force AB and force C, so I can assume any direction. Okay, if I assume FAB, okay, FAB is here, FAB is point down, and FC is point up. Okay, I just random assumption. FAB point down, FC point up. Okay, could I also get the correct answers? Okay, yes, let me show you. Okay, and later I will show another initial wrong assumption. You still get the correct answer. Okay, and in the sign convention we still the same. In sign convention we still point up is positive and counterclockwise is positive. Okay, yeah, counterclockwise. Oh, maybe my notes is wrong. Okay, first of all, let's go the rigid body equilibrium. Okay, rigid body equilibrium. Oh, okay, equilibrium. Okay, first of all, because we only have vertical force, so we only do the force balance on the y direction. So we have minus force AB and minus 3 is units kilonewton, and plus FC is equal to 0. This is for summation Fy equal to 0. Okay. The other is the total moment of the system 0. Let's use the point C as the reference point. So MC equal to 0. Okay, so that means we have FAB with reference point is C, so it will it's a clockwise. Sorry, it's counterclockwise. Or let me see, it's counterclockwise or clockwise? Its reference point is C. Oh, okay, it's counterclockwise. Okay, yeah, counterclock. So it's FAB times 200 millimeter, and there's another force 3 kilonewton here. 3 kilonewton here, and it's also counterclockwise. Counterclockwise, yes, counterclockwise plus 3 times it's 200 and 200. It's 200 minus x. Yeah, 200 minus x equal to 0. Okay, so this is a rigid body equilibrium. But in this problem, we will have another criteria to solve the problem. He said the member AB and the support C have the same tensile stress or normal stress. Okay, don't forget the stress is force divided by area. So we will have the FAB. Here I use the absolute value. Okay, here FAB divided by 400 times 10 to the power minus 3 square equal to, okay, 4C equal to absolute value, because he still needs to say that the normal stress is the same. I think its magnitude is the same. Normal stress, tensile stress magnitude is the same. Okay, so it's 650 times 10 to the power minus 3 square. Okay, with all these three conditions, and then you can solve the, okay, I think you can solve the problem. Okay, so let's see. Okay, we first of all we solve this. If we start with this condition first, and for this condition, if you use your engineering calculator, you will have the FC magnitude, FC equal to 1.625 and times magnitude of the force AB. Okay. Okay, so right now it's the magical part. Okay, so don't forget our initial assumption is force AB point down and force C is point up. Okay, so so if we want to abandon the absolute value, yeah, we have to be careful, because force C is point up, force AB is point down. So this will give you this relation. Okay, this will give you FC is minus 1.625 FAB. Okay, because this force we initially assume is reverse, if it's opposite direction. So if we want to remove this bracket, absolute value bracket, okay, we need to put the minus sign here. You can put minus sign here, it's all right. Okay, it's the same. Okay, so if we have this relationship, okay, we can put this relation to I think which way is proper, put which equation. Let me put color. We can put this in this equation. Okay, that's much easier to solve. Okay, so we will have the minus FAB minus 3 and minus 1.625 FAB equal to 0. Okay, and then you will get a minus 2.625 and FAB equal to 3. So it gives you FAB is, okay, minus 1.14 yeah, 1.143 kilonewton. And also, okay, at the same time, you can also give you the FC. Can I get the FC? Okay, also at the same time, FC is equal to, so we know FC is minus 1.625 times FAB. So you times together, so it will give you the 1.875 kilonewton. Okay. Okay, let's make a pause here. Okay, let's look at this explanation, make an explanation of this result. Okay, so we get the FAB is, if FAB is minus 1.143 kilonewton, and initially we assume this is point down. Okay, but we get a negative answer, so that means the real direction is 1.143 point up. That's the real direction, 1.143 point up. Okay, and initially we assume FC is point up, and we get positive value. So actually, the real value, the real direction of FC is also point up, 1.875. So initially, even if I made the wrong assumption of FAB, I made a wrong direction assumption for the FAB, I still can get, finally I still get the right direction of FAB and FC, even if I don't know the real direction of AB at the beginning, but after the calculation, I still can get the right answers. So even if you initially make a wrong assumption, you still can get right. You still can get the right answer. Okay. Okay, and let's put this value in the momentum balance equation to get the final answers. Okay, so FAB here is negative. Okay, so we still use negative. Okay, be careful. Here we just put a negative 1.143 times 200 plus 3 times 200 minus x equal to 0 to solve the x. Okay, to solve the x, let's see. Okay, what's the value here? It's 2 minus 228.6 and plus 600 minus 3x equal to 0. So okay, I think you can solve the x. What's the value of the x? Okay, the value of x is equal to 123.8. It's the units millimeter. Yeah, here the length is with the length, the unit of length is millimeter. Okay, and the force is kilonewton. Okay, so even if initially you made a wrong assumption, initial assumption direction of FAB, you still didn't get the right answer. Okay, let's raise the other example. Even if I make the initial force FAB and FC, I make I assume the both direction wrong, I still can get the right answer. Okay, so let's do this again. If I force AB and force C, and then initially I make a wrong direction assumption, what will happen? Okay, so let me draw this again. Okay, draw this problem again. Okay, here, same thing, here. Okay. Okay, so let's see. Here is 3 kilonewton point down. Okay, if I assume initial FAB point down, initially FC is also point down. And here is X, and here is the 220 of 200 millimeter. Okay, so under this wrong initial assumption, could I also get a right answer? The answer is yes. Let me show you. Okay, but I didn't make. Okay. So, and what's the sign convention here? Yeah, the sign convention we still use the typical sign convention. Point up is positive and counterclockwise is positive. Okay, same thing. Rigid body equilibrium. Okay, so FAB, we only consider the summation Fy equal to 0 because we don't have only vertical direction. Okay, so FAB minus FAB and minus 3 minus FC equal to 0. And also the other condition, summation MC equal to 0, so we'll have the, okay, this FAB times 200, and it's counterclockwise, so it's positive, and 3 and plus 3 also counterclockwise. 200 minus x equal to 0. And the other condition, the normal stress on the AB section and the CD in the section, suppose section C is the same. Okay, same thing. Okay, so we also use this we also start from this condition. This condition, okay, we already know it's give you the FC equal to 1.625 FAB. Okay, right now I want to make this absolute bracket disappear. Okay, here be noticed because initially I assume FC and FAB they are in the same direction. Okay, I assume initially they are all point down. So when I remove the bracket, you don't have to change sign. So this also give you the FC equal to 1.625 FAB. Okay, then use the same strategy. Put this equation back into this equation. What will you obtain? You will obtain. Okay. You will obtain a minus FAB minus 3 minus 1.625 FAB equal to 0. Okay, so after all, you will have the FAB equal to minus 1.143 kilonewton. And then you will have the FC equal to minus 1.857 kilonewton. Okay, let's make a pause here to think what's the really mean of this answer. Okay, initially I assume FAB and FC they all point down, but finally I also get a negative value. Okay, that means the real direction of FAB and FC is point up 1.143 kilonewton, and here is 1.857 point up. Okay, so even if initially I assume the wrong direction of the forces, these two forces, okay, after the calculation I still can get the right direction of this force after calculation, even if initially I make a wrong assumption of the direction of these two forces. After calculation I still can get the right direction of these two forces. Okay, and then let's go further. Okay, could we get a right answer for the x? Okay, so here FAB is minus 1.143. Okay, so we just put this value back into the momentum balance equation. Okay, put this value in there. Okay, minus 1.143. Just put this value in this momentum balance equation. Okay, and times 200. Okay, and then plus 200 minus x equal to 0. Okay, so let's see. Okay, what's the answer? I think it's 2 minus 228.6 plus 600 minus 3x equal to 0. We still get the same answer. The answer is 123.8 and the unit is millimeter. Okay, so I use this examples 7.7. I make two wrong initial force direction, but finally after the calculation I still can get the right direction of the force and the answers. Okay, hope this can make you get more understanding of the initial assumption of these forces. No matter what, just keep, once you assume its direction, just following your sign convention and do the calculation step by step. Finally you will still can get the right direction of the force, even if initially you didn't assume the correct direction or right direction at the beginning. Okay, so this is a video. Okay, so I'll stop here and see you next time. Bye bye.